So let's go through an example so that you know how to complete this. And so you are going to need your periodic table. And let's go ahead and do carbon together. Okay, so carbon, look up carbon on your periodic table and find it. And when you find it, just holler out, what is the symbol for carbon? Yep, so I'm going to put a C there. What's the atomic number for carbon? Yeah, so let's look and see how we find atomic number. I'm going to use my legend. The top number on my periodic table is atomic number. So the atomic number for carbon is a 6. Okay, the atomic mass, go ahead and tell me what that is. 12 what? 12.0. So it says atomic mass. Remember, the atomic mass is the full number with the decimal. If you round it, then what is it called? Mass number. So two different things. You should be putting the whole number there because they ask for atomic mass. Okay, mass number is a different thing. Okay, number of protons, how do you know what that is right away? Yeah, very good. It equals the atomic number. So number of protons is the atomic number. Now when I find the neutrons, I didn't give you your own numbers. So you're going to need to take your atomic mass and round it to the nearest whole number, which would be what? 12. And then you subtract it from your number of protons. So 12 minus 6 would give you 6 neutrons. Okay, so since I'm not giving you any numbers here, you'll take your atomic mass and round it to the nearest whole number, subtract it from your atomic number to get your neutrons. Do you have any questions about that? Okay, as we look, we see no charges any place. So how many electrons must it have? 6. So electrons are the same as protons. Everything on the periodic table is neutral. They have no charge. Now it says the number of valence shell electrons. So I taught you how to do this before, but let's work through it again. There's actually a couple ways you can figure out how many valence electrons carbon has. So first of all, let's just back up. What's a valence electron again? The ones in the outer shell. So there's a couple things you should probably have memorized. Everything in group 1, do you remember we talked about this last time? Everything in group 1 has how many valence electrons? 1. Everything in group 2 has 2. Everything in group 13 has 3. Everything in group 14 has 4. So you could do it that way with our patterns of 1, 2, 3, 4, 5, 6, 7, 8. If you forget that, you have the answer on the periodic table. So remember we talked about this last time. See those teeny tiny numbers? It's the number of electrons in the energy levels. And so if you forget how many electrons go in the first shell, you have the answer right here. If you forget how many go in the second shell, you have the answer right here. So use your periodic table, use the tools you're given. So for carbon, how many valence electrons does it have? I have the answer on my periodic table. If you want the number of electrons in the last shell, you look at the last teeny tiny number in every box on the periodic table. That's the amount of electrons in the last shell. Does that make sense? So how many valence electrons does carbon have? 4. Now if you look, how many does silicon have? How many does germanium have? Everything in group 14 has how many valence electrons? 4. Your answers are on the periodic table. Does that make sense? Okay, so I will put number of valence shell electrons, 4. Now it says draw a board diagram. You're going to have to make them small, and you might have to make one here, and then the next row make one here. So to draw a board diagram, I always have to draw on my nucleus. And I always have to indicate the protons and neutrons in the nucleus. And, we do like to have the element symbol there. So C for carbon, 6 protons, 6 neutrons. And I'm using one of these felted pens, so it's kind of big and gloppy there. But I've got 6, I have the element C for carbon, 6 protons, 6 neutrons. When you draw these, I like you to do a solid circle for the nucleus. What's outside of the nucleus? Good. And now I got to start drawing my energy levels. So I'm going to draw a dotted line to represent the first shell. That's my first energy level. So energy level, shell, ring, orbit, they mean all the same thing to us. How many electrons can fit in the first shell? If you forget, your answer is on your periodic table. How many electrons are in the first shell? 2. So you're going to draw on 2. And you can just use solid dots. And make them big so we can see them. Like, just don't do a dot on the pen. Your electrons should go in, think of it as clock positions. And electrons, remember, have like charges. They're going to repel each other. So they want to be as far away from each other as possible. So start at 12 o'clock, put one in at 12, and put one in at 6. So our first shells should always look the same. All right. So carbon has a total of 6 electrons. I've got 2 in, and I need to put 4 more in my last shell. And you can double check your work because you have the answer on your periodic table. So 2 in the first shell, 4 in the second. And if I put them in clock positions, I'd have 1 at 12, 1 at 6, 1 at 3, and 1 at 9. At this point, you should just double check your work, check your numbers. Well, you said there were 4 valence electrons. Did you draw 4 electrons in the last shell? You said it had a total of 6 electrons. Do you have a total of 6 electrons in there? Okay, so just check your work when you draw your Bohr model. Does anyone have any questions about how to draw the Bohr model or how to know what to put where? Is everyone understanding? McKenna? No, I do want them in the spaces. Yeah, we want them in the spaces. Trey?
So like the first shell, should have like 4 dots?
No, the first shell will just have 2. Only 2 electrons can fit in the first shell. Every first shell will only ever have 2.
And then the second one, that's going to be after that.
Yes, and you can put up to 8 in the second one. Okay.
Okay, thank you.
Yep. All right, so the number of electrons the atom gives up or needs to be stable. Now, this is what you need to think in your head. And carbon has 4 valence electrons. What do we want to have in our last shell? How many electrons does our last shell need?
4.
Yeah, it needs 8, so it needs how many more? 4, or it could give up 4, right? So good. So we know the number of electrons the atom gives up or needs to be stable. It needs 4 more, or it needs to lose 4. And carbon is one of those. We never talked about its charge. Actually, I never gave you the oxidation state for carbon because carbon is one of those that it actually won't do either. It won't lose or gain. Carbon actually will share electrons. Okay, so anything out of group 14, it could either lose or gain. For your purposes right now, it actually does neither. Okay, so let's do another one where you actually have to pick a choice if it's going to lose or gain. So let's do another example. Let's do phosphorus. Let's do phosphorus. Okay, so P, I already told you the name, so it's phosphorus. Okay, atomic number. If you look at your periodic table, someone shout out, what is the atomic number? Atomic mass. Good, 30.97. The amount of protons. Good. Any questions about how to get any of those numbers? All right, so now when we get to neutrons, remember, what do I have to do with the atomic mass? Good. So it'd be 31 minus 15. So how many neutrons? Good. Total number of electrons? 15. Number of valence shell electrons. So take a second, think about it, get it figured out. Okay, so how many valence shell electrons? 5. Can you tell us how you figured it out? So you looked at this number, Dallas?
No, the one.
You looked at that one. The last tiny number means there's 5 in the outer shell. Remember, these are the number of electrons in the energy levels, and the last one is the last shell, so there's 5. Okay, now we have to draw our Bohr model. So we need to draw our nucleus. We put our chemical symbol. We write that there's 15 protons and 16 neutrons. Now I need to draw my first energy level. How many electrons go in your first level? 2. Yep, always 2. Again, if you forget that, use your periodic table. It tells you. So if I look here, that first tiny number is a 2. Okay, my second tiny number already tells me there's going to be 8. So draw your second shell, put in 8. Okay, so I put them in clock position, so 12 o'clock, 6 o'clock, 3, and 9, and then you start doubling them up. So another one in at 12. They don't like each other, they want to repel, but they also go in as pairs. It's kind of a weird thing. If you want to know more about that, you could take Honors Chem or AP Chem or Chemistry in college. Okay, so I've got 10 electrons in there. It had a total of 15. So not just using my periodic table, I should also know I need 5 more in, right? Because I have 8 in right now. I had a total of 15. I'm sorry, I have 10 in right now. I had a total of 15. I need to put in 5 more. So I'll put 1 in at 12. We're following our same process, clock positions. 1 in at 6, 1 in at 3, 1 in at 9. And then again, when you go back around, you double them up. So my last one should go in at 12. If your electrons don't look exactly like mine, you won't get it wrong. It's just helpful if you put them in these clock positions so when we do look at it, it's consistent. Does that make sense? Okay, so if you don't put them in the clock positions correctly, it's not wrong. It's just this helps for consistency. All right, so number of electrons the atom gives up or needs to be stable. So it's got 5 in the outer shell. This outer shell needs how many to be stable? It needs 3 more to have a total of 8. So this will need or gain, okay, so it's going to gain how many? 3. It's going to gain 3 electrons to be stable. All right, does it make sense what you need to do? Okay. You can actually check most of your work if you're not sure if you're drawing your Bohr models right. Slide 29 has all the Bohr models for you, but I think you should be able to do it using your periodic table. When you get them all drawn, open up slide 29 and check your work. Okay, and then when you've checked your work, you can start answering the questions here on the last page.